The James Webb Telescope has just revealed the clearest image of Proxima B in history, uncovering astonishing insights into a conceivably livable exoplanet. It obliges us, as we set out on an excursion through space, to uncover the mysteries of Proxima B and find out whether it may be the next Earth. We ought to take off into the tremendous region of space where a puzzling planet exists in the habitable zone of its star Proxima Centauri. This planet isn't simply any common stone. It's Earth C. Proxima B, found a mere 42 light-years away from us, is covered in secrets and wonders. Might it be another Earth with oceans and life proliferating on its surface? Anyway, wait, there's something else. Proxima Centauri B isn't the only one in its orbit around the red dwarf star. It has a companion, Proxima Centauri C. Who knows what other mysteries the star system holds? Maybe there's another companion that we have yet to discover. The secrets don't stop there. Proxima Centauri begets roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life? As we adventure past our own solar system, we find a completely different universe of exoplanets. Planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander free, untethered to any star, like revolutionary explorers in space. Among them all, Proxima Centauri B stands out as a particularly striking and fascinating planet, with a year that lasts just 112 Earth days and a distance from its star that is many times closer than Earth is to the Sun. More than likely, one side of the planet is continually washed in sunlight while the opposite side remains in eternal darkness. Now, let's talk about Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our own solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak brightness of under 2.7. Proxima Centauri, otherwise known as Alpha Centauri C, is a red dwarf or M-type star found 21 light-years away from the other two stars, generally multiple times the distance between Earth and the Sun. It is, in fact, the nearest star to us. Proxima Centauri means the nearest star in Latin, discovered in 1915 by Scottish astronomer Robert Thorburn Proxima. Regardless of being our nearest celestial neighbor, it isn't visible to the unaided eye. It has an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth wondering about. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. In reality, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one thing, it's a flare star, meaning it has frequent and intense outbursts. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be between 0.23 and 54 cents. However, it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, many times stronger than the radiation we get from our Sun. That's right. It's so intense that even the lightest atoms of hydrogen are stripped away, not to mention nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living organisms would be vulnerable to harsh space weather, making life almost impossible. So, while Proxima B might seem Earth-like on the surface, it is far from being able to support life. People remain somewhat skeptical, as there are many factors that render it uninhabitable. The mission to reveal the truth about Proxima B continues. Some people still hold hope. One instrument that has caught the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. As with everything in science, things are never as clear as they appear to be. Various adjustments were needed to ensure that the James Webb Telescope delivered accurate images. As Abby Bend, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light in the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. However, what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is usually denser than Earth's and extreme heat that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B isn't without its challenges. While the James Webb Telescope holds promise, there are various factors to consider. With costs mounting, space scientists are under pressure to find ways to observe planets like Proxima B. The stakes are high, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the promise of life, is a motivation worth pursuing. If the exoplanet were habitable, could we one day visit it? It's the closest exoplanet to us, which makes it so exciting, almost like exploring our vast backyard. Even more captivating is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an optimal target for our search for life beyond Earth. With it being so close, it's a fantastic contender for interstellar missions. Consider the chance of exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology progresses, it's one of the most thrilling adventures in the field of space exploration. However, it's no simple task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nevertheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima alongside it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. But, as with anything this ambitious, there are limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is unsuitable for life. Moreover, get this, the James Webb Telescope has the ability to detect such illumination if it reaches a brightness of only 5% of the daytime side. Now, 5% might not seem like much, but when dealing with a star that is generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations that are illuminating its surface, they may be using brilliant orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our own Earth. But what do we know about them? One type of exoplanet that has captured the attention of space scientists is the gas giant. These planets are similar in structure to Jupiter and Saturn, but are much larger. Some of these behemoths have been dubbed super Jupiters, dwarfing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a searing world with temperatures that could melt metal. Imagine seeing such a planet up close, with its raging storms and intense heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are the hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from afar. And we must not overlook the terrestrial exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our world to twice its size. There are even super-Earths, which have masses over twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b isn't alone. It has a companion, Proxima Centauri c, which is significantly farther from the star. This planet has an orbital period of about 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more fascinating about Proxima c is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary companion. If confirmed, this planet will be known as Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars as well as countless other planets, each with its own unique composition and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be an astronomer. While we don't yet have a precise count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not easily detectable, and it requires cutting-edge technology and modern telescopes to identify them. These planets are often obscured by the glare of their host stars, making them challenging to study. However, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and detectable from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a captivating glimpse into the characteristics and composition of these distant worlds. Exoplanets are most commonly discovered through the changes they induce in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided significant information about exoplanets, including their size, distance, and temperature. Here are some fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets like those in our solar system can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets are ready to be discovered. NASA's James Webb Telescope is revealing the secrets of the universe one discovery at a time. This remarkable telescope has been gathering data and capturing stunning images of the universe, uncovering previously unknown wonders. Recently, it made history with a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides essential information about the planet's composition and development, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding marks a significant step in our search for extraterrestrial life. NASA Director Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen, igniting excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing stunning images and gathering data about the universe in the infrared. The light from the young, outflowing protostar named 110 IRS-4 illuminates the cool, wispy cloud material, and the orange dots behind the cloud reveal light from distant stars darkened by the ice in the cloud. This remarkable investigation was part of Webb's Ice Age project, which aims to study the formation of ice, from its creation to the development of icy comets. And that's not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared. This finding gives essential insights into the formation of planetary systems and could help us understand how our own solar system was formed. As we look to the future, the possibilities for exploration and discovery are limitless. With ongoing advancements in technology and our understanding of the cosmos, who knows what other secrets await us among the stars? Each new finding takes us one step closer to understanding our place in the universe and the potential for life beyond our home planet. The quest continues, and the journey of discovery is only just beginning.